Okay, so to find the textbook, you go to modules, and then resources is right here. The first one says Connect Ed online textbook. You click on that. Load it in a new window. And then yours is going to look a little different than mine because I have more choices. So I'm going to click on the student edition. When you first get there, this is what it should look like, okay? Y'all, there are tons of resources in here. If you click on this menu up here at the top, all kinds of resources come up. Extra help, there's videos, all kinds of stuff, okay? But what we want is on the far right-hand side where it says ebook. Click on that. And here's where some people were saying on phones and iPads it wasn't working. If you have a desktop, it works just fine, okay? I'm not sure why it's not working for iPads. Maybe there's a block, pop-up blocker or something. So from here, down at the very bottom, do you guys see there's like a box for you to enter a page number? If you enter 105 was the page that I said to put to go to. The view defaults to 2 pages. See how my screen looks like 2 pages? Okay, you can also put it on just single page, and then you go forward this way. All right, you can, I'm just looking for my zoom here at the top. You can zoom in, see, like that. And this is where we're going to be working. So you guys have a hard copy of the notes today, but also this is in the textbook. So we're going through the lesson. Today's homework comes from, oops, this page right here, which is page 109. That's where our homework comes from, which you do not have a copy of. So you're going to have to either go to the textbook, or I did put a copy of it back in today's module, Thursday. Notes key. Here's the homework textbook, and then look, I also put a PDF version if you are having trouble getting to it, so we can work on it at the end of the class. Okay. Okay. So anyway, we had our test yesterday, and so now we're moving into add, subtract, multiply, divide now with rational numbers. What does that mean? Using what? Decimals and fractions. That's exactly right. Okay. So today, y'all, today's lesson is honestly a review from 5th grade. Okay. My experience so far today has been a lot of kids are like, yes, I got that, I know that, and other kids are like, I'm not so sure. Remember what happened in the spring? What happened in the spring? Yeah, we were staying home after spring break, right? So maybe depending on where you were, you might not have gotten back into class. There we go. So what they've done on this first page is just kind of a way to introduce the lesson. They're saying that the table shows the weight of a 1-pound object on each planet. What we mean is something that weighs 1 pound here on other planets weighs different amounts. You probably already knew that from science, right? Okay. So therefore, a 1/2 pound object on Earth would weigh half as much as a 1 pound object. That makes sense. Okay, so look at number 1. It says if a cheeseburger weighs 1/2 pound on Earth, what will it weigh on Jupiter? So that means I need from Jupiter that the weight would be 2.3 pounds. So would you be heavier or lighter on Jupiter? You would be heavier, right? Because if you're a pound here, let's say you're 100 pounds here, then how much would you weigh on Jupiter? 230. Oh my, I don't need to live on Jupiter. Okay. Anyway, so now number 2 says to write a multiplication expression to represent this situation. So that means Jupiter is 2.3 times as much as it is on Earth, right? Or you're writing one line, you're writing. And so it says it's a 1/2 pound. What number is going to represent 1/2 pound? Either 1/2 or 0.5. Okay? So then either to the side, somewhere wherever you've got space. Right? We just multiply as normal. Yes, this is 5th grade work. Now what? That's right. You have to count how many decimal places you went over. We went over 1, 2, so that means I'm going to go over 1, 2, and put my decimal there. So that means something that weighs a 1/2 pound on Earth is actually going to weigh 1.15 pounds on Jupiter. Yes, ma'am. Right, but we want the expression, and then here they run the answer. So I just did it all at once, but thank you. Okay, number 3 says, what would a barbell weigh that weighs 5 pounds on Earth weigh on Jupiter? So this time, we still were using 2.3 because that's from Jupiter, but what number am I going to multiply by? By 5 because it's 5 pounds. Okay, so I'm going to go over here to the side and multiply by 5 pounds. 1 decimal place, 1 decimal place, and I get 11, oops, that's not where I want that. I'm going to put it up here because I'm running out of space. 11.5, okay? So now, what I want us to look at is these 2 problems. My 2 works that I did here. What do you guys see that's the same about them? Part of the same. Yeah, we both have 2.3. What else is the same about them? Exactly. So you can see we have 1, 1, 5, 1, 1, 5 on both of them. So now what's different about them, everybody? Where the decimal is. That's exactly right. So does this look familiar to anybody? Remind you of something. Say it again. Homework. That's right. This should remind you of the homework yesterday when you had to fill out that table and I said you could do it with a calculator. You should have hopefully looked for patterns. We're going to talk about that tomorrow. Okay? Good. So now, if we did, when it was just times 5, it was 11.5. The decimal was here, right? But when it was 0.5, look what happened to the decimal. It moved over a place, yes? Okay, so now let's look at the next question. Without working it, we want to analyze what we just did, when we did that, to now solve 0.05 times 2.3. 0.05. So without actually doing the work, we already know that the numbers are going to be what? 115, right? But now, let me get it back so we can see this one. Where's our decimal now going to go? To the left one more from where it was here, right? Where it's going to end up here. Okay? So it's kind of like looking for a pattern. Okay? Okay, next page. All right. So remember when I said we don't use the textbook a lot? There's a reason why. It's just okay sometimes. This is one of the places where I wish that they had done a better job. Okay? Because when you model something, this model is mostly correct, but it's not 100% correct. Okay? What I mean is, it's 0.7 times 0.6, right? Well, really, 0.7 should have been, that's 7/10, right? So that should have been all the way across. So guys, shade that all the way across. 7/10 would have been all of them. Okay? The whole way. You actually have our base 10 blocks, which we're going to talk about tomorrow, more base 10 blocks, okay? 0.6, 6/10 would have been the whole way. Are you shading with me, guys? If I'm writing, you're writing. All right? And now, the answer is where they overlap. You guys see that? Yeah. So, if I could, what should I count to get the answers? Yeah, it's where they overlap. It's the total squares where they overlap. Okay? So now you can see that it would be 6 of them by 7 of them, so how much is it? 42, but because it's tenths, really this is 42 out of, how many are here all together? 100. It's 42 out of 100, right? Well, how do we write 42 hundredths as a decimal? 0.42. Okay? So this is kind of like showing you why we moved that decimal, because it's out of 100. Okay? So here you're just summarizing that to multiply decimals, you can multiply just like you do with whole numbers first. place the decimal point in the quadrant, you find the sum. What's that mean? The total of the number of decimal places in each factor, the product has the same number of decimal places. Okay? So let's see how this one, 0.8 times 0.9 would be 0.72, because 8 times 9 is 72, and then there's one place, two places, so that's why it's got to go two places over. Is this kind of coming back to you guys from fifth grade? Yeah, all the way. Good. Okay, let's do this one together. Okay, 2 times 2 is 4, 2 times 1 is 2, 2 times 1 is 2, perfect. How come there's a gap right there? Good, okay, so because it's like multiplying by 10, so that's not obviously going to be a 0 or just move over. So then 7 times 2 is 14, 7 times 1, 7 plus 1, 8, and then 7 times 1, 7. And now what? Just add. Okay, and then we went 1, 2, 3 places. This one was just one place. Okay, one place, really. You're not going to undo that for me? Okay, fine. Whatever. 3 plus 1 then would be 4 total places. So from the end, 1, 2, 3, 4, and that's where our decimal goes. Ask me.
Why you can tell is it's behind the decimal is behind the decimal. Count that and then whatever.
Wait, I don't understand your question.
I don't know how you're moving the decimal bars. No. Because okay, because look, if whatever behind the tenth place, which is like decimals, like you count those and then you do that with your product again, and then what you do is you move that many spaces to the left, and then you set this number. Still a little confused.
So what she's saying is, okay. All right. So, I have a question for you. Did anybody realize or notice? Look at that original problem. In general, when we multiply, what are we expecting to happen to our answers? When we multiply by decimal. Oh, but I said in general, when we multiply, we expect them to get bigger. But what's happening here? You actually got smaller. Why is that? It's because we multiply by something less than 1. See that? So if you want to put yourself a little note over here. When multiplying by something less than 1, it gets smaller. Because basically your whole academic career, really, you've been dealing with mostly whole numbers, big numbers, and you always get bigger. And so we're going to talk about this some more next week when we move into fractions. But when you multiply by something smaller than 1, you're going to end up with an answer smaller than 1. So what if you multiply by something bigger than 1? It's going to get bigger. Okay? I'm sorry, I messed up. When you multiply by something smaller than 1, your answer just gets bigger. Smaller, you guys. Not smaller than 1, just smaller than what you started with. Okay? Okay, so what I'd like for you guys to do is we're going to do 2 of these. How about you guys do B and C on your own? If you're at home, pause the video. Okay, check your answers for B. Did you guys get 0.2060? Yeah. And for C, did you guys get 0.042? Yeah. Excellent. All right. Questions? Good? Move on? Excellent. Next page. So now we're going to put it in a real world context. It says a certain car can travel 28.45 miles with 1 gallon of gasoline. The gasoline tank can hold 11.5 gallons. How many miles can this car travel on a full tank of gas? Justify your answer. Okay, first of all, when you see justify your answer, what does that mean? Well, it can mean show your work.
How you got it.
That's the same as show your work. Justify your answer means kind of, does your answer make sense? Okay? A key here, especially when we're talking about decimals, is you want to estimate. What does estimate mean? To round, that's exactly right. It means you want to use easy numbers to get an answer on your own, okay? So in this case, what they're saying is 28.45 times 11.5 is the real work we're going to do. But instead, we want to round that to 30 times 12. How many of you right now, you're like 28.45, that really rounds to 28, right? And 11.5 is 12. How come this is not what they used to estimate? Why did they do 30 times 12? Yeah. Well, yes, because the whole point of an estimate is that I need to be able to do it in my head. And while some of you geniuses might be able to do 28 times 12, I can't do 28 times 12 in my head, but I can do 30 times 12 in my head because 3 times 12 is 36, so then 30 times 12 would be 360. Exactly. So this is my estimate. Really, you want to be able to do an estimate in your head. If you can't do it in your head, then that means you probably didn't pick the numbers in the first place. Okay? So now what they did was they went ahead and did the math, 28.45 times 11.5, and they got 327.15. So now when we compare that to the estimate of 360, it's close-ish. Okay? It's not going to be exact because the further away that you get from the real numbers when you do your estimate, then that's the further away that it's going to be when you're comparing it right here. Okay? But it's reasonable. Okay? So what I would like for you to do down here is 3, 4, and 6. I want you to estimate first, then solve. Okay? And then check your solutions with your estimate. If they're not close, then you obviously did something wrong. The whole point of that is to see if you get a reasonable answer, okay? If you're at home, pause the video. Okay, so check your answers was fine. Notice that you should see my estimates. That squiggly little equal sign, what does that mean? It means about. Okay, so when you see a squiggle equal sign, that's not an exact answer, that's an about answer, because that's what my estimate is. Okay, the little check mark that I put there, what does that mean? Right, that means my estimate on the first one was 1 times 7 is 7. When I worked it out, I really got 6.86. So I'm like, check, those are close to each other. Okay. Number 4, my estimate was 3. I got 3.645. That's close, right? Number 6, my estimate was 0. My answer was 0.0848. Isn't that really close to 0? Yeah. Okay, so now what I want you to do is number 8 says, why is estimating not as helpful when you're multiplying very small numbers, such as 0.007 times 0.053? Take a second to think about that. Why would estimating not be very helpful on that one, Alex? Huh? I'm sorry? Why would that not be very helpful, Matthew? Right, because they both round to 0, which means your estimate's going to be 0, right? So that's why it's not very helpful. When those numbers are very, very small, then you're always going to be very small. Okay? Are we good? Okay, next page. All right. Now, another thing that the textbook loves to do is it loves to give us one really good word problem. And it's so good that they take an entire page to talk about it. Okay? So, I want to spend a little time on this because you might see something like this on an upcoming assessment, okay? It says, the table shows the cost of produce per pound at a farmer's market. Mr. Gonzalez bought 0.75 pounds of pears and 3.5 pounds of plums. What was his change from $10? Okay, step 1, they're telling you to analyze. What does that mean? That means to read it and understand exactly what they're talking about. Usually that means you need to read it again, right? And then underline or circle important things. Okay? So let's read it again. The table shows the cost of produce per pound at a farmer's market. Mr. Gonzalez bought 0.75 pounds of pears. Does that sound important? Yep. And 3.5 pounds of plums. Also important. What else is important that's not in the story? Yeah, from the chart, guys. I need to know that pears cost 98 cents per pound, and we also need to know that plums cost $1.49 per pound, right? Okay? And then it says to underline what the problem is asking you to find. What was his change from $10? Okay? So now we've analyzed it, meaning I hope we have an understanding of what we're looking for. Now step 2, we want to make a plan. And guys, making a plan is not doing your work yet. You're just like thinking about what you need to do. So what do we need to do here?
Find out the total.
Yep. And then subtract to get the change. That's exactly right. So you should be thinking right now, this is a multi-step problem. All right. We first got to figure out how much you spent. Then we got to subtract. Okay. So now let's do a little bit more down here. The solving is where this is where most of you lie. Most of you like to jump right to there, to the solving aspect, without really digesting what the problem is about. And that's where mistakes happen. Okay. So solve. We need to do 0.75 pounds of pears times what?
Times
0.98. Please don't do it yet. We're still just making our plan. Okay. Then the plums, we need to do 3.5 times what? $1.49. Okay. Then we need to get the total. So that means we're going to take these two amounts and what? Add them to get the total, right? And then once we get them, then we'll subtract from 10. Okay. So pause the video and work it. You guys can work it, and then. Okay. Let's go through the problem. Okay. So for the pears, you should have done 0.75 times 0.98, which should have given you 0.735. You guys all get that?
Yeah.
Okay. For the plums, y'all should have done 1.49 times 3.5, which should have given you 5.215. Okay. So that's the cost. So then you needed to add them together to get the total cost of $5.95. You guys all get that? Okay. Then to get the change, you had to then subtract from $10 to get $4.05. Okay. So then that makes the answer what? Hey, $4.05. Let me show you something. Look at B. Ooh, where'd B come from? Yeah. I mean, there is a 595, but can you see? That's, you guys, test makers like myself are really smart, and we know what kids do. Sometimes what happens in a long problem like this, you get what I call lost in the problem. And you're like, you're working, and you got 595, and you look over at the answers, and you're like, yes, I see 595, and that's it. But then you skip a step, okay? So you just got to be careful. All right, now the last one I want to talk about is, how do you know if your solution is accurate? How do you know, I mean, aside from the fact that we did all this work, how would you know it's accurate? Look at my thing.
You add 5.95 equals.
Oh, to see if you get back to 10? Yeah, but what about, remember when I talked about justifying? What could we do?
Estimate it.
Yeah, we can estimate.
I estimated it first, and then I did.
Well, that's good. That's good too.
I thought you
So let's,
the ground first, and then.
right? Absolutely. You start with, yeah, let's talk about that then. Okay, if we were going to estimate, I'm trying to see if I have a color that I haven't really used yet. I don't really use purple. Okay. So if we were going to estimate, instead of saying 0.75 pounds, what would we say? That's about what? Instead of 0.75, that's really close to 1 pound, right? And then instead of 98 cents, that's really close to what? So really, 1 pound at $1 would be about $1 on the pears. Okay? Then up here, instead of saying 3.5 pounds plums at $1.49, we would say he bought about 4 pounds instead of $1.49, $1, which would be what? 4 pounds at $1 would be 4 pounds. So together, what would the total be? No, $1 for pears and $4 for plums. So that would be $5. So then my change would be $5. Is that sort of close? Yeah. Really close. Okay? Okay. So guys, what I'd like for y'all to do, your homework is page 109 in the textbook. So those of you that have your computer, not a phone, you may go through the textbook that way, or you can just go in the modules. I put a picture of this and do the odds only. What does that mean?
1, 2, 3, 5, 7, 9.
Thank you. Thank you. Okay?